Hello and thank you all for joining us today for this educational Innovise webinar. My name is Caitlin Nine and I'm part of the marketing team here in the Innovise Portland office. In this webinar, we'll discuss how modeling is changing and how different packages handle different situations. For those of you who may not be familiar with Innovise, we have a long history of providing high-performing, innovative software solutions. Our intention is to make sure that in your work, you can design, model, review, and manage with confidence. This also means that we strive to provide excellent customer service and support, and that we offer continuing education opportunities like these for engineers and others in our industry. Innovise offers a library of software programs for the design, analysis, and management of water infrastructure, including sewer, storm, and flood modeling, like InfoSWMM, which you will see today. Now on with our presentation. I'd like to introduce our presenters. Today's presenters are Matt Anderson and Bob Dickinson. Matt joined XP in December of 2016 as the product manager for XP Swim and comes with very valuable experience, especially for today's webinars, as he spent 6 years with Autodesk, most recently as a product manager. He spent over 16 years as a private engineering consultant, and over the past decade, he's been involved in providing workflows and technology that engineers use to study and design civil infrastructure and water resources. Joining Matt today is Bob Dickinson. He joined XP's in December of 1991 as a developer for XP Swim and comes with very valuable experience, especially for today's webinar, as he spent 40 years answering modeling questions with the University of Florida, XP Software, CDM Smith, and Innovise. He's been at Innovise for the last 11 years as a product sector leader for InfoSewer and InfoSWM. He did spend 8 years as a private engineering consultant, as he has had valuable experience improving modeling workflows. Thank you again for joining us. Would you like to start our discussion, Matt?
Thank you, Caitlin. I do. And before we get too far, I'd like to just get to know who's here on the webinar with a couple of questions. Kind of hopefully set the stage, if you will, for the topic today. So let me just activate that poll. So what is the source of your greatest challenge in assessing your model and the model results? Are you a firefighter? You didn't build it, you didn't start the fire, but in my best Billy Joel, you need to put it out. Are you a rookie? Are you kind of overwhelmed with all of the digital data, CAD, LiDAR, GIS, RAS models? Oh my. Are you a judge? Are you questioning the assumptions and reviewing results and asking why things are the way they are? Or are you a builder? Are you just love to dig in? You love that smell of concrete in the morning. Where it's just a matter of building it, right? It's not really a challenge, you just do it. So I'll let this vote tally go up and I'll share you the responses here in a second. So pick one. Which is the source of your greatest challenge? All right, in 3, 2, 1. I'd like to get up to about 75%. We're pretty close. So good 40%. I think that mimicked the first session's numbers a little bit. I think firefighter and builder have swapped. It'll be very interesting. So good number of you are either rookies with the data or you're a judge and builders. So cool. Thank you. Let me hide that one and go to the next question. Launch that poll. So which of the following 5 best practices do you implement when dealing with digital data? Do you get a lot of observational data, a lot of calibration information? Have you built an information exchange protocol? So for this log or for this GIS data, we want to make sure we only capture this, or so that you kind of have some idea where you're getting your information from and how you're getting it. Do you deal with a model definition log? We'll get into the details of that, but another one, do you skeletonize? Do you just simplify the world down to critical elements and that's really all you deal with? Or none of the above? Probably could have made this a much longer set of questions, but I'm limited with 5 options. And this one is multiple choice, so if you happen to do model definition logs and skeletonize your model, you can select both of those. So 5, 4, 3, 2, 1. Let me share that result. Good 70%, 71% observation data. Good 50% of you do skeletonize, just deal with the model and only identify those critical elements. Good. All right. Let me flip over to here. So our agenda, oh, come on, pause, unpause, there we are. Our agenda is primarily here to help us identify, with this prevalence of data in a digital form, kind of address this kitchen sink issue, right? Where we tend to just dump data into our models and think about how different packages have handled this situation, right? Modeling logs, kind of a systematic level of development, how to become a better modeler, okay? And then we'll cover some of that in InfoSWMM. So just a little history. The idea of this kind of came together as a bit of a Venn diagram here, if you will, from some support cases that I handled over the month of December. Came from a couple of LinkedIn posts and conversations. It also hit me when I began to review, not review, but a book preview from Gutenberg to Google, The History of Our Future by Tom Wheeler. Great little shared PDF, but it has a very interesting connecting the nuclear weapons to Gutenberg, right? And how certain acts and certain ideas from different fields kind of help bring about certain events, right? The concepts came across. So kind of pull that together with some experiences that I had as a product manager, and I'm going to rely a little bit on Bob to help bring some of these connections together. Okay. So borrowing this slide from a conference presentation that Bob Dickinson did, and I think it captures definitely really this entire model cycle, right? We have that real complex world at the bottom there, okay? We have observation information. We have GIS data. We have monitored data, okay? And we build a model. I'm kind of a flood modeler myself, storm and flood, hydrology and hydraulics. I mean, this probably is very applicable to modeling beyond sewer, storm, and flood. But I'm just going to focus on that because that's kind of where I'm strong at. So we build these models so we can kind of study, right? So we study the response, hopefully to be able to gain some insight on that complex world, because there's a lot of things going on. But we do that, hopefully using this data to help distinguish what's important, what's critical, right? And over the history of my career, and I'm assuming obviously the history of all of our careers, there's been a lot of change, right? You know, one of the key elements of change, really, you know, we've got a lot of digital data. You know, we tend to capture more. Great question. I didn't cover it in the first session, but I'm going to cover it now. Is a lot of this overwhelming sense of digital data comes from a progression in the data acquisition, right? You know, GPS, LiDAR, you know, even Moore's law, really. You know, I'm on the desk next to me is my iPhone. That iPhone has more memory than my first computer, right? It's amazing what we've been able to do with technology. And that technology is giving us that ability not only to generate more data, but really being able to then model more information, right? And that's what this webinar is kind of focus on. Will focus on is being able to tame those building blocks, that enable us to build the model. Okay. So back history. My first experience with SWM was this project, right? And it goes back some time. Not that version there, but that's just a screen capture. Back to the DOS days, right? Graphical Windows interfaces, Windows hadn't been, or was just coming out, you know, but I learned SWM 4 from my professor there, Dr. Hotalin, and my first role as a project engineer was to look at a flooding problem in this location, right? We've got all of this green space, all of these homes, and you know, the sewer system and the overland flooding would kind of flood where that blue arrow is at, right? So my task was to model, you know, new inlets, new piping, ultimately providing an expansive stormwater pond here in that location there. The image is back when it was built, but you know, I didn't have a lot of really good photos like this, right? Back in the day, a lot of paper, a lot of preliminaries. You know, it was something that, you know, looking at that old manual, and it's probably packed in a box somewhere in my house, but there's nothing graphical. You know, there was a lot of young engineering judgment used to build that model, right? And I'll readily admit I struggled, right? I struggled with reducing that image of Stager, Illinois, and identifying, you know, what needed to go where, right? Wrong, too fast there. But yeah, so it was a simple model by today's standards. But you know, SWM has made definitely leaps and bounds in computational ability. Obviously, Moore's law has helped with that. This is InfoSWM SA. These are four models. I think back in the day, Bob, tell me about, you know, SWM modeling back when I.
Sure. Yeah, thank you, Matt. Yeah, actually, those are 6 models. Those are the actual test models we had for SWM 3 and SWM 4. Each one of those little models, about 9 links, took about 5 minutes to run in 1987. So you spent a lot of time waiting around for things to run. So each one of those used a inflow hydrograph of 6 hours. So to run a 6-hour simulation for nine links with surcharge took about 5 minutes. For me to duplicate that 5 minutes, I'd have to run these models for 50 years. So that's a 75,000 times speed up from 87 to now. So over a 30-year period, that's a fantastic increase, allowing us to make really good and faster and better models.
Yep. And obviously with faster and better models, we probably need more faster and better data, right? So, yeah. So, you know, this is one of the example 1D, 2D models. It goes back a number of years. Is it Toon-Gaby? Is that correct, Bob?
Yeah, this is actually the first XP-SWM model in 1993, developed by Brett Phillips of Willing & Partners, who was instrumental in helping develop XP Rafts from XP Software in Australia. But they had an interesting place called Toon-Gaby. It was one of the first settlements in the 1790s outside of Sydney. And the problem there is they settled these cities when it was very dry. So they basically built their cities in the floodplain. And they built really tiny footbridges and little like cart bridges. So what happened is when it ever started raining, the whole place would flood. So for them to model basically the outskirts of Sydney, they needed to develop these sort of sketchy 2D models using 1D elements. And it was pretty creative the way they did it. Basically, the flow would be routed around the houses, down the streets, using a 1D elements. So ever since the beginning of XP-SWM, we've been interested in 2D, or at least quasi 2D modeling.
Yeah. There's obviously a lot of engineering judgment to reduce that terrain down to these collection of links, right?
Right. Sure.
Obviously today with XP-SWM and InfoSWM and ICM, we can import digital terrain models and, provide some pretty stunning visualizations, right? So, with better data, we can definitely get a better understanding of the results. But one of the things that I kind of do is, gives us the opportunity a little bit for mimicry, right? Biomimicry, if you will, is to, mimic nature with our elements, So I want to take a kind of a look at some of the digital revolution really in some other similar or related fields, if you will, and see if we can learn something from how those fields are tackling this digital problem, right? And, this is where some of my experiences at Autodesk came together. We had, I sat in a number of consulting opportunities with Autodesk and with my architectural friends. I was on the civil infrastructure side. They were on the Revit side. But this level of development, I think it was developed originally, put together by Vico Software, was a way to help begin to define kind of the reliability and suitability of different model elements. And Vico called it level of detail, so LOD, and it's become, intermixed with level of development, right? Level of model detail, level of definition, and it's given way to identify something like a foundation, wall, and help define what the stage is and what's the model purpose, right? So there was a shared understanding from modeler to modeler, how much detail was in a model, right? From a simple, hey, there needs to be a foundation wall here, to something as simple as, hey, there's a notch at the top right here, okay, to ultimately, what are the fabrication components for rebar, for certain elements, and things like that. That level of development, I think, is a good stage, something that we as modelers probably begin to need to, and maybe us as software teams need to help begin to drive some of this conversation. So the publicly available specification 1192-2, here's a bunch of these documents. The British have done a really good job with building information modeling, or BIM, in helping define how they want projects delivered in the UK. And this concept here, this is one of the concepts in this paper that really help begin to define what's expected across, say, different models, or what, the systems that they're covered across that, right? So it's not just level of development or level of detail, but what is, what information can be relied on? What is interpolated? What is correct and what is assumed, right? So this hopefully helps drive something like that across these different model development stages, right? So one of the things obviously in that last one was, kind of that build over to handover to operations, right? So they've even developed a British standard, 8536-2. It's called the Briefing for Design and Construction Code of Practice for Asset Management, with a nice little subtitle, Linear and Geographic Infrastructure, right? Hey, that's stuff we model today, right? So I will admit that I liberally adapted Figure 3, which has a lot more lines and a lot more bubbles, to kind of the main points that I'm going to try to drive at here, okay? In this case, Figure 3 really talks about identifying what the required outcome is, right? And then getting into a common data environment that's that ISO number there. Knowing the details of that data, what's the desired outcome, asset outcome, right? How do you validate that data? Do you need to then come back and acquire more information, okay, to get really not only the project information model complete, but make sure that the project outcome is met, right? And that drives an impact, okay? So a lot of process stuff, okay, that we can potentially think about. And a great example, really, is our workgroup functionality, right? InfoWorks ICM. Well, it has a sister product called Info Asset Manager. Well, Info Asset Manager is the asset management data repository piece, right? That InfoWorks ICM can very easily step up onto and work with that data. Last year, I did a webinar on workgroup productivity, right? On how to work collaboratively and, resolve conflicts with digital data, using tools that we've built into InfoWorks, called data flagging. We can share that same space. There's a link on our website to go that. I encourage you. In fact, I talked with someone earlier this week who had just recently watched this, okay? And they were pretty impressed with what was going on there, right? I was here in Portland, Oregon. Nathan was off-site in Texas, and we were working together collaboratively on the server in Broomfield. So it was pretty neat. I was able to check something in live. Nathan was able to grab that information, resolve those conflicts, and then perform some simulations. It was pretty neat. Okay, that's one way software can help us tame some of this build digital data, taming that, for building models. Another example, back to BIM, right? We have that ability to take a look with the BIM Change Log, right? On the GISA website, there's a small little snippet that I borrowed here that came from Vistera, right? It's a change log, more on physical changing, right? An as-built tracking log, if you will, that might give us a framework for tracking model information. Obviously, the date of the change, what changed, what is it, who was responsible for it, what work was completed in that change and things like that. So and then there's comments, right? So that concept, I think, it flows through what I'd call a model log, right? Model name, date of change, who made that change, details and comments, and then the results that those changes made, right? So, in a couple of those support cases, kind of struggled with trying to identify, what some of those things were intended, right? It might be something that I need to ask when reviewing this. Is like, hey, what changes did you make, right? What was the purpose? What is this available? And this example came from TwoFlow. TwoFlow's partner of Innovise with XPSWM and XPStorm. It's pretty much something. Obviously, any Excel spreadsheet probably can handle that, right? It's not built into the software, but would encourage you to consider some steps like this, right? And we also have different ways to do it, right? InfoSWM has a model tracker, InfoSWM SA. This is this little screenshot here that is a snapshot of that. So you can take notes here in that change. So talking about InfoSWM, kind of want to talk about the InfoSWM release. And I think we're going to be getting that up here shortly. Version 14.7, InfoSWM on ArcGIS, and then InfoSWM SA 2.1, which is a standalone. One of the things that we did recently here is to kind of get that up with the SWM engine so that we will now have EPA SWM 5.1.13, right? And there's quite a bit of changes, but corresponding tables and reports and a new calculation engine method, and then your requisite maintenance, right, to make sure things are good and stable, right? So, Bob, if we're going to switch over to you here in a second, but we've added a new SWM engine option, and EPA SWM has it, where we currently swap out or give you the ability to model the Priestman slot or Xtran, right? We have some catchment time patterns, which I think is pretty cool. And I don't know how many of you guys are being affected by the polar freeze, whatever the heck this giant cold is, but that's something that I think, modeling how those catchments happen in frozen conditions is probably pretty neat there. So, Bob, let's go ahead and make you presenter.
Thank you, Matt. Screen. Okay, do you see the screen yet?
Yep, I got it. Thank you.
Okay. Thanks for the great introduction and wonderful history of modeling, and quite an exciting period of time we live in. As Matt mentioned, this new InfoSWM 14.7 and InfoSWM SA, which stands for standalone, which uses the Arc engine, 2.1 is built on the EPA SWM 5.1.01.13 engine. And the important parts of this is the fact that with the LIDs, you can now use an LID or a SUD to capture both the impervious and the pervious flow. And that's a very good feature. I should mention that a lot of these new LID features from SWM 13 are also in ICM 9.5, and others will be in later versions of ICM. A lot of additions to the LID permeable, so you basically clog things over time. So a lot of these additions are basically for continuous simulation. So you can better model seasonal changes in roughness and impervious and depression storage. You can better model seasonal changes in your LID. You can basically have drainage in your LIDs as a function of curves. And you can have patterns, as Matt mentioned, for the ends. Another really big thing is the fact that you can now have LID removal. Before, you were limited in that the LIDs basically did a great job of changing the hydrology of the subcatchment, but it didn't affect the water quality. Now you can have a fixed removal percentage for any kind of water quality. Okay, another good thing is the surcharge depth for nodes. So now you can basically model your system with either a manhole or a storage node, and have that storage node act as a pressurized container. So that makes it a lot more flexible. You can now basically model your system with different areas. A really big thing is the adding the slot finally to SWM. So a pre-SWM slot based on a SOGRIA algorithm for the area allows the model to be more stable. So there's no longer a situation where you switch from the St. Venant solution to a surcharge algorithm as things pressurized. Everything is basically the St. Venant. Should mention that the slot has been in XPSWM and obviously InfoWorks ICM for a very long time. Okay. Other things are periodic additions to how you do control rules. Okay, and weir discharge coefficient. So let's look at how this affects the model. So here's kind of a classic situation where the default XTran, which is basically the SWM3, SWM4 surcharge algorithm, wasn't very good. You basically have a system that doesn't have an outlet. It's basically a tunnel system, and you get continuity error at the links, at the nodes rather. So let me come over here and run this model for you. So you go over here and you go to dynamic wave and you pick the default, which is XTran. So I'm just going to run that as XTran. Okay. And we'll go to report manager, and report manager will have wrong guy. We'll have a continuity error of 61%, and it'll list where that is. And the reason for that is because the XTran solution sort of had an issue with these kind of systems here. So anytime you would have a situation where there was an offset between one link and another link, it kind of oscillated in between here as a move from one to the other link, and then eventually got surcharged. So the slot allows you to basically do that transition a lot easier. So let's switch to the slot now. So we go over here to the slot, and we go to dynamic wave. And the reason it's not the default is not the slot is because XTran was the default for so many years. So for existing models, we leave the default as XTran. So come over here, run it again. All right, and now we'll go to report manager again. Refresh that. Now the continuity error is down to 3%. And if we look at a particular link here, and the reason it's down to 3% is it doesn't kind of get stuck. So it basically follows what's happening in the real system better. So that's been a tremendous improvement in that. We should also mention that we have hundreds, if not thousands, of test cases, and we basically simulated with and without the slot, and you get really good answers with the slot. Another feature in the hydraulics part of InfoSWM 14.7 is the fact that you can now do time step averaging. What that'll do is it'll average the nodes, node depth, and links over time, so it can better match calibrated or monitored data. So instead of using instantaneous at the beginning and end of a report time step, you now can get the average over a particular time. So that'll help you with the calibration. Another thing that it has is under time step, it has a control rule time step. In the existing SWM 5 and InfoSWM, you basically at each time step, no matter how small the time step was, you would evaluate the control rule. Now you can change that and basically do it every minute, every 30 seconds, every 5 minutes, etc. So it's less. You basically don't have to change back and forth between the rules. So that's kind of a neat little thing there. All right, so that's basically the hydraulics. What was probably more important, especially for those of you who do hydrology and water quality, is the LIDs. So in the LIDs, what you can now do is you can have control over the drain. You can have an open and closed level. Basically, a lot of these new additions, really nice additions by the EPA, Lou Rosman in particular, were done so that it's a better continuous simulation model. So over many events, you can open and close. You can basically control the drainage by a control curve, so that you can simulate what goes on during the year. More importantly, though, there's now this percent removal. So for each water quality constituent in the LID, you could say, I'm going to have 50% removal, 25% removal, 33% removal, etc. And that'll be built in on top of whatever hydrology effect it has. So you can better simulate what's going on. Sorry. All right. So let's just go ahead and run that. Oh, and also let me just come over here for a second. One other very important thing, and it's also in ICM, is under LID usage. Previously, you'd only treated the percent impervious area. So if you had a rain garden, for example, you would only give it the percent of rooftop or driveway that goes to that. Now you can also have percent impervious and percent pervious. So if you have a rain garden around your house, you can also capture part of the pervious area, and that's another really nice feature to make it better suited for modeling LIDs and SUDs, and that particular part is also in ICM 9.5. Okay. All right, so go ahead and solve this. All right. Now we'll look at the cistern. And we'll compare it to, so anyway, you can see the effect here. So for total nitrogen, we didn't have any removal. The total nitrogen is the same with and without the removal. Total phosphorus, the green is with a BMP removal. The blue is without BMP removal. So you can see that has the effect of lowering the concentration and lowering the load to that system. Another nice thing about, especially InfoSWM with the LIDs, it has an LID graph. So for example, if I wanted to see my rain garden again, I can see a lot of different aspects of it, soil percolation, etc. Or if I wanted to look at everything together, I'll come over here to the reference graph, pick multiple axes, and I can see everything that's going on in the LID directly, so you get a better idea of what's going on. So in this, it's new InfoSWM SA, and EPA SWM 5.113. A lot of really nice features for LIDs, and especially for the slot for hydraulics. So a big improvement to the hydraulics, and a really nice improvement to the water quality and LID components of the program. And another thing is the pervious, as Matt mentioned, so that you can now, I think on Twitter it's called Chiberia. Apparently Chicago is really cold. So anyway, so if you're trying to model the frozen Midwest of the USA or Canada, you can now have a pattern and have a monthly pattern for Manning's N, depression storage, and infiltration rate, etc. Okay, and that basically covers the new features. Really nice features. Some probably over should have been there a long time ago, but it's really, the slot in particular and the LID features in particular are really, really cool. Okay.
Cool. Thanks, Bob. Bob, one question here. You know, how do you determine which to use, Xtran or slot?
Okay. Well, one way would be to basically by the continuity error. I would kind of prefer the slot, to tell you the truth. So I would try the slot, and then if I didn't like the answer, then I wanted to switch back to Xtran. But I would go by the continuity error and how it basically fits the transition from partial to surcharge flow.
Mm-hmm. Okay. Yeah. So and I think you touched on it there, where ICM as well as XPSWM already, you know, that's their default method, right?
That is the default method in those two products, yes.
Yeah. So you know, but we've got the ability to there. You didn't show it here in the second one, but there is the way, you know, we can do, and you could compare, right? You can compare those two different scenarios in the different charts there. So you could,
I didn't do it the second one, but in InfoSWM you can have it has a very nice scenario explorer. So I could have run two. I did run two scenarios with and without the slot, so you can see the answer directly on your screen.
Yeah. Cool. Another question was, and this goes a little bit, you know, because we've talked about what our architectural friends have done with tools like Revit. You know, Autodesk is adding features that facilitate HVAC consultants to perform modeling and simulations directly within that BIM model, the architect's BIM model. You know, and that's provided, you know, facilities managers, you know, a great advantage, right, in BIM modeling, right? There's no information lost. And the question is, you know, are we suggesting that water agency should look forward to such a similar future, right? BIM modeling, construction documentations, hydraulic simulations, and et cetera. So, and I'll address that. Yeah, I think that's possible. One of the elements that I didn't include, I know Autodesk and Esri have this wonderful interconnecting loop connecting the GIS world to the BIM world, if you will. I have a feeling as these partnerships across these spaces grow, right? You know, that you know, we might eventually in the future get to a place where data doesn't get lost, you know, doesn't get or the right amount of information gets passed between asset and design and planning and data collection. So I think that's a good lofty goal. How fast we get there is always something that I think is up to you as customers, right, to communicate to us. You know, I'd love to have a conversation with anybody who's willing on what that future is and how quickly we go. That's kind of the role of the product manager. So when you get your survey, if you want to have that conversation, I'm glad to take those questions there. So cool. When will the new version be released? It should be up on the website, I think by the end of this week, given we've got a couple of web pages to edit and get the software there available. So I anticipate, I think the end of the week is the 1st of February. So that's, is there another question? Is there a plan to get the new InfoSWM on FEMA approved model list? Well, since it is running SWM, right? It's a SWM engine, somewhat already there, right? So, cool. Well, anyway, thank you for Caitlin and for Bob. I want to thank you for joining us today, whether you joined us in this webinar or listening in the recording. Thank you. Thank you again. Again, feel free, both my email and Bob's email are listed there. So we would gladly take any questions and go from there. Thank you.